6:15 if it's a rough morning.
All right.
Because I'm like, one more time. It's the alarm.
All right, so questions on the study guide? No? Do it? Which ones? So the spermatogenic cells, they're the ones that turn into sperm. Oh, I'm sorry. So that's the process? The genesis is like the verb? Or is that a noun? It's the process. I guess that makes it a noun. The actual cells that are going to turn into sperm. All right, let's go ahead and take our quiz then. Yeah, because there's the female half. We did finish 27, right? Yeah. We finished 27. That's what I'm feeling. What?
Yeah, 5.
Oh, they're all over here. All right. Check your phone notes.
Look, I go. I know, really.
Yes, anymore.
Yes.
I was stupid and drank like 16 cups of decaf.
Oh, jeez.
And
Terrible.
All right, so what's the fibrous capsule inside the testes called? It's the tunica vaginalis.
Yes. Which I think, I don't know, I feel like I should know.
I know, right?
The name? I don't know why.
Yeah, it's kind of,
Yeah.
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 That's why I put it on there, just to remind you that is part of the male system. Where are sperm made? Is it the seminiferous tubule,
Yes.
scrotum, or tunica? Seminiferous. Seminiferous. Say that 10 times fast. Which of these is not an accessory male sex gland? They all are. And they're glands because they produce like fluids and whatnot. Secrete stuff. Which of these is a muscle? Dartos. And which cells produce testosterone? Interstitial, exactly.
I think we got it. And Sue's like, everyone got that's pretty good.
Wait until next.
Like the kidneys, it was like cricket.
Yeah, the male system's a little bit easier to understand, I would say. All right, so just to kind of remind you why we do meiosis, what it is. So obviously, mitosis, you already learned about. Wound repair, it's replacing all the cells of your body all the time. Growth of a baby, all that stuff. But meiosis is when you're making haploid gametes, either sperm or eggs. What does haploid mean? Half of something.
I can't remember it.
So it's half the chromosomes of your other cells. I heard you were whispering that kind of. And that's because if you're going to make a baby, it better have the right amount of chromosomes, hopefully. So that means the sperm needs to have half of them, and the egg has to have half of them. So they have a whole separate process, which is meiosis, which you learned about in 201 back in chapter 3. That's the process. So in males, that's happening in the seminiferous tubule. In females, where do you think it's happening? It's in the ovaries, right? All right. The main thing that people get mixed up on is they think that meiosis is sexual reproduction or something. It's not. That's like the next step. Meiosis is only making those cells. And then sexual reproduction is the fertilization part. So it's separate. And I think it's confusing because, you need meiosis to do sexual reproduction. But meiosis is its own. It's like the first step. All right, so components. You've got the testes that make the sperm, epididymis. It's kind of the tubes for storing it. Vas deferens, that's the first duct. And it takes them from the epididymis all the way to the ejaculatory duct. It's a foot long. It's a pretty long duct when you think about things in your body. And we'll see a picture of that one. And then the ejaculatory duct goes from vas deferens through the prostate to the urethra. And the urethra is the exit point. All right, there's our different glands and what they make. So seminal vesicles, they make like most of the secretion, 60% of the volume, and it's alkaline fluid and fructose. And so the reason those are there, alkaline fluid, that's basic, right? So it counteracts the acidic environment that the sperm are headed to. And fructose is energy for the sperm because they've got mitochondria. They're going to need energy to do all that swimming they've got to do. Prostate, citric acid, it's also energy. And an antibiotic, no one really knows why it's in there. There's some ideas, but there's no proof why that's there. And then more alkaline fluid from the bulbourethral glands. All right, what else? Here's the picture of the whole thing. We'll look at the testes a little more detail in a little bit, but you can see the epididymis right on there. It's kind of its separate structure. I got to see those a lot when I was doing a bunch of mice castrations. So you'd snip open the the scrotum, pull the little testes out, and you'd always see like this epididymis just kind of hanging out to the side. Did that to cats? Calves? It's fun. I know, otherwise it wouldn't taste very good, right? It's true. I remember at my grandpa's ranch, they used to do it to cats with like no anesthesia or anything. It's like the country way, and they'd like put them in a bag, like a burlap sack, and like just pull them out the side. It just seems really horrible. How many people like to eat those? Raglan oysters? Anybody? Yeah? There's no way I would ever eat that. There's no way. Yeah?
We do, they go have enough fries.
High school did their FFA oyster fry.
Uh-huh. 750 pounds? Oh my goodness. That's crazy. All right, so anyways, seems kind of strange. Like how is that vas deferens a foot long? Like that distance isn't a foot, right? And that's because it starts at the epididymis and takes this crazy roundabout path. So it goes past the bladder, around, and then that's kind of the end of it there. So there's the seminal vesicle. Where's our other glands? There's the prostate. And the urethral gland is right there. And then the ejaculatory duct is pretty short. It just goes from the end of the vas deferens to the urethra right here. And here's the bladder, the urethra. So that's where they kind of meet up. Right. Maybe you've wondered why they're hanging out there. It's mostly temperature, at least we think. And that's because, for whatever reason, and I put that why there, but actually turns out we don't know why it's most efficient, but that's the most efficient temperature to make sperm is 35. What's your body temperature in Celsius? It's like around 37. So it's like 2 degrees Celsius, which is what, like 3 degrees Fahrenheit or so. And you maintain that temperature by moving them closer or farther away from the body. Closer warms them up, farther away cools them down. Kind of interesting, I think. And it's the dartos and the cremaster muscles that kind of respond to that. Also, what do you think the fight or flight response would do to this? Yeah. Why would you do that? Why would it do that?
It's fight or flight.
Yeah, it's safety. Because thinking about evolution stuff, like if those get damaged, your genes don't get passed on. So you want to save them away, keep them. All right, you can resort to less extreme measures, I think. All right, so to make sperm, got to go through meiosis. It's happening all the time after puberty, just constantly. I forget the number, but it's a lot. So you start with diploid cells. They're basically sperm or stem cells. They divide in half. One of them stays as a stem cell, and then the other one is going to go into meiosis. So it becomes a spermatocyte, divides once to make a secondary spermatocyte, and then it divides again to make 4 spermatids. And that N number, 2N is diploid, N is haploid. So down here you've got haploid cells, and then they develop in the seminiferous tubule to the completed sperm there with their little tails. Right, so that's all that. I think I said all that. Once the sperm get developed, they actually move through the ret. Actually, I forgot how to say that word. Actually, yeah, rete, I don't know, testes, and they go to the epididymis, and they kind of complete their development or learn to swim. Kind of get completely developed there. And this picture kind of shows you. So there's all these little compartments that are the seminiferous tubules, and then as they get closer to being completed, they come over here to the rake testes and get pushed along into the epididymis. And so that's what's full of, mature functional sperm. And then here's the vas deferens, also known as the ductus deferens. There's a little sperm, so it's got the head, which is mostly just the nucleus. The neck is full of mitochondria, because obviously they need energy. And then the tail, for movement. It's a little mini propeller there. One thing, it's kind of fun. You heard about the guy who invented the microscope in England, like in the 1700s or something. So one of the first things he was asked to do, and this is by like the Royal Science Society of England, is find out what's in semen or whatever they called it back then. Because no one knew how reproduction worked. They're like, you do this, and then somehow a baby starts growing. Like they didn't know it was like sperm or eggs. Like no one really knew how it worked at all. And so that's one of the first things he was asked to look at, which is kind of interesting little tidbit. It's like, don't look at plants, don't look at this. They're like, find out what's in there. We want to see how babies are made. And here's, so because so many sperm are made like all the time, the body doesn't worry too much about making perfect ones. Because if you've got 1 million of them, do you need all of them to be perfect, or can 10% of them be all messed up, right? Doesn't matter. So you've got normal ones. So you can end up with all these different sperm morphologies. That's normal. And you can see a bunch of examples of messed up ones. So if you're doing like some kind of, fertility testing, they look at the number, but then they also look at the morphology to see if there's something like, do all of the sperm look like that? That's probably going to mess things up a little bit. What about hormones? There's lots of hormones involved in this. That's what we're going to spend most of our time on. So at puberty, way up in the hypothalamus, it's signaled to produce the GnRH, which is gonadotropin releasing hormone. Do you remember learning about it in chapter 18? Wait, we didn't do that yet, right? That's the last chapter, or second to last. So you'll see more about it, but it's made there, goes to the pituitary, and it tells the pituitary gland, which is also up by the brain, to make 2 other hormones, luteinizing and follicle stimulating hormone. Kind of a surprise, females also have those hormones, and they were kind of named for that, right? Males don't have follicles, but it turns out we do have that hormone. And the luteinizing hormone tells those interstitial cells to make testosterone, and the follicle stimulating hormone tells the testes to make more sperm, basically. So at puberty, more testosterone, start making sperm. That's kind of the idea. And it wouldn't be an anatomy class without some feedback loops. It's a good thing we have them. I mean, you don't want excessive testosterone, right? Roid rage, craziness. So you have the GnRH, the LH, FSH, and then it's all kind of controlled by negative feedback. So testosterone's made, and it tells the hypothalamus to stop making GnRH, and it tells the pituitary to stop making LH as well. So you're stopping in two places. And then for follicle-stimulating hormone, when you're making all those sperm, it also makes inhibin, which goes and tells the pituitary to stop making FSH once you have like enough sperm. Yeah, and we're going to practice a little bit too. But yeah, this would be the slide to look at. And one more thing though. Testosterone is actually not all that strong of a hormone. Most of its effects are after it gets turned into dihydrotestosterone or DHT. And so that causes, making males look like males, right? After puberty. But you do make some before, because obviously boys look different than girls, right? And then at puberty, you get all those changes. And this is interesting. Anabolism. So it tells you to make basically more proteins, muscles bigger, because obviously men have just larger muscles on average, just because. That's from DHT as well.
But like, when you get prostate cancer, they cut that, and then you stop producing a lot of testosterone, because you lose the muscle.
And they shouldn't. I don't really know, because the prostate's way up here. It's not like in the testes. I haven't heard of the lower. Is that a common problem, you think? Take out prostate and get low testosterone?
It lowers.
Huh.
I don't know why.
I don't know why either.
I don't know if it's like, in general, like, you can see better to know, but.
I mean, I do.
I know it's like a side effect.
Yeah. I mean, I certainly know why you have issues with incontinence, right?
Right.
Because, look, the urethra goes right through there, like in the middle of it. So, how do you take that out and keep all these muscles and pieces all together?
People with low testosterone that get injections.
Yeah.
With testosterone.
Yeah.
Yeah, if you ever watch sports or listen to sports on the radio, that's like all the ads you hear. Are you tired? Do you not feel like you're 18 anymore? Maybe you have low T.
Yeah.
Maybe, or maybe you're just older.
Maybe you're not 18 anymore.
Right, I mean, that's basically what they say. Have you heard those ads?
Yeah.
Somebody? Yeah.
Yeah, they're usually at a gas pump.
Oh, at a gas pump, too?
And they
Interesting.
say, with low testosterone, actually develop osteoporosis as they get older too.
Yeah. So, I mean, not to disparage it, I think low T is like a real condition, but I think it's quite a bit overprescribed.
Right.
And that can actually damage your heart. So, it's probably not the best thing. Although we'll see, my grandpa's been on it for like 10 years. He's no problems yet. So. All right, so where were we here? We got all lost. All right, so we talked about the negative feedback. We talked about testosterone and DHT. Oh, one other thing that's, I think, interesting about testosterone's not up there. Have you noticed that men hold their fat in different places? So where do guys mostly have their fat usually? Right? It's like all like abdominal. So you could see a guy who's really fat, he's got this big belly and just like normal everywhere else. That's hormonally influenced by testosterone and estrogen. So high testosterone puts fat there. High estrogen puts fat basically everywhere else. It's like more hips and other places. Have you ever kind of wondered why that difference is there? How you can You can go get some low T patches.
I don't know how you explain that to you.
You might get you might have some other male features come out that you might not want as much, like a beard but hey, it's up to you. I wonder what they would do at one of those centers if you went in there and you're like, I think I have low T. They're like,
I think so too. Ma'am?
That'd be funny.
I don't know, it's not being.
All right. Seems really. All right, so I've got a little review for all these hormones, especially because I think last time I did this chapter, we had done the hormone chapter already, so I kind of forgot.
Endocrine tissues contained in the hypothalamus of the brain.
Maybe before we do all that, what is a hormone, just in general? Okay, how does it travel around? It is part of the endocrine system and it travels in the blood. It's a chemical, it binds to cells or goes inside of cells and like tells them to do stuff. All right, so y'all kind of
Anterior
know.
pituitary and the testes.
So hypothalamus and pituitary in the brain, and then the testes is kind of the response organ.
In the hypothalamus, certain neurosecretory cells secrete gonadotropin-releasing hormone. Gonadotropin-releasing hormone is carried by the blood to the anterior pituitary, where it binds to receptors on gonadotropes and stimulates the cells to increase secretion of two gonadotropic hormones, luteinizing hormone, or LH, and follicle-stimulating hormone, or FSH. LH and FSH are transported in the blood to the testes. LH and FSH both indirectly affect spermatogenesis. LH binds to receptors on Leydig cells between seminiferous tubules and stimulates the secretion of testosterone. Under the influence of FSH and testosterone, Sertoli cells produce androgen binding protein. ABP binds to testosterone and maintains high levels of the hormone near the spermatogenic cells.
You don't need to worry about that.
Under the influence of testosterone, Sertoli cells nurture the stem cells and the developing sperm cells. Testosterone stimulates the final stages of spermatogenesis. In addition, testosterone is converted into dihydrotestosterone, another hormone that may promote sperm cell formation. Testosterone and dihydrotestosterone both bind to the same intranuclear receptors. Together, the androgens regulate male prenatal development and the development of male sexual characteristics. Sertoli cells release the protein hormone inhibin when the level of spermatogenesis required for male reproductive functions has been attained. Inhibin is delivered by the blood to the gonadotropic cells within the anterior pituitary. Inhibin acts on the gonadotropes to reduce FSH secretion and thereby decreases the rate of spermatogenesis. Similarly, testosterone acts in a negative feedback manner on anterior pituitary gonadotropes to suppress the secretion of LH. The negative feedback effect of testosterone also involves its effect on the hypothalamus, the result of which is decreased secretion of gonadotropin-releasing hormone. Decreased secretion of gonadotropin-releasing hormone causes a corresponding decrease in the secretion of both LH and FSH. The decrease in LH causes a decrease in the secretion of testosterone by the Leydig cells in the testes. Low levels of testosterone reduce spermatogenesis. Conversely, an excessive decrease in testosterone allows the hypothalamus to increase its secretion of gonadotropin.
All right. I think that's probably enough. All right, so I've got some questions for you to work on. Oh, actually, we skipped one. Let's do number 1 first. So just work on that one with your group, and then we'll go over it, and then we'll go on to the next one. Kind of forgot about the basics. So question 1 for now. What, testosterone is a controlled substance? It is. I know when I used it in the lab, it had to be like specially stored,
Yeah,
and
I thought
we had
it
to fill all these forms to the DEA and stuff.
Estrogen was popping those like crazy, but testosterone, you gotta sign your life away.
Yeah, meatheads. So that's why. Jeez, these people can't close the Play-Doh. It's like they've never used Play-Doh before.
Stimulates.
So think about what all these hormones do.
Yeah.
Stimulates what? And we're trying to keep it simple.
This one does too, I think. Is this one produced in the testes too?
No, those are produced in the pituitary gland.
Oh, you were right then. She was right.
Cool, and the GnRH is in the hypothalamus.
The hypothalamus?
Uh-huh.
I was wondering, we were debating between the two.
So what does it make them do? What does GnRH make the gonadotropes do? Is it which ones? So it tells the pituitary to make those hormones.
It stimulates
The GnRH.
in the
I would say both, honestly. If you put either one, I'd accept it as right. Yeah. Uh-huh.
So would you say that it, like,
Yes, that's what I would say.
do you have to do anything about the ADP? Because that's just the hormone, right?
It's a binding protein. It's not really a hormone.
'Cause I don't really understand.
Yeah, I'm not worrying about it.
Create LH and
Oh, yeah, you're right. Yeah. So I would say for LH, you said the function is produce testosterone.
Well, stimulate testosterone secretion.
That would be a better way to say it.
Okay.
Or tell the testes to make testosterone or something.
And then yeah, that's what you write.
Developments of the male sexual characteristics.
So LH, you say control secretion of testosterone. Which direction? Increase or decrease?
Increase?
It's just a,
Development of male.
all right. Forgot about that.
He has low T, but he has the T of a newborn.
Oh, wow.
And I'm like, that would suck.
Whoops.
How does the body have? Wait, are these the testes?
No, it's fine. It looks like that. That's the pituitary.
So the brain?
Yeah.
So they're formed in the produced and all that? Hormones produced in the pituitary.
Yeah, they're like a little bit below the brain, but yeah, they're like basically in the brain. But then testosterone and stuff, I wish they would have shown it, but yeah, everything in the bottom half is in the testes.
Oh, so like this would be right
Like
here.
from right here down?
Yeah, like if you just circle that and wrote testes next to it.
Right here, right?
Yeah. Yeah, no wonder. Why didn't they just include the...
So then this is, so it's in the testes, right?
No, it's in the testes.
Because look, it's on the bottom. That's what he said.
Yeah, the interstitial cells are making it.
You know what I mean?
And they're in the testes.
Stop. Sends it to the hypothalamus. The hypothalamus will help them stop. You know what I'm saying? So it's not like
And what?
it sends it.
Oh, on the, yeah.
Because it'll know. It'll like what you were saying.
And where are the interstitial cells? Like broadly, not specifically, but where are they? Are they in your brain, your stomach?
Interstitial.
They're in your testes. Yeah. Right? I realized it wasn't like written on there anywhere.
Yeah, I saw something in the book. It said, but it was like a weird description. It wasn't just like in
I know, but that's all. That's what I want
the
you to know.
posterior portion of, I'm like, what?
On the backside.
Yeah. Yeah, and once you get that first table, I guess you can go on to 2, 3, and 4 with your group there. Yeah. For what? The males? Like male characteristics,
Is
Yeah.
it those 3 bullets?
Uh-huh.
Yeah.
Yeah.
So, we want to be the pituitary, or be the interstitial cells, right?
Well, something happens something tells the hypothalamus to do something. What is it?
Well,
Interstitial
the,
cells? No, that's.
What do you
What
mean?
is it, the LH?
No?
Is it that G word?
No?
No, the inhibits with the.
What would make sense if you don't want too much testosterone? Looking at that diagram, what would you want to do if you had a lot of testosterone? Do you want to make more LH or less? So that's what this is saying. Testosterone stops LH and it stops GnRH.
Oh.
Right? It's a negative feedback loop.
Stop.
She said it, but I don't know where it is.
Yeah.
For
It's,
this one has 2 hormones that stop, right?
what stops?
Testosterone.
Yeah.
Excessive.
What is it? So if you have lots of testosterone, what is it? How does it turn off that diagram that you're looking at? Well,
How much GnRH and LH increase? Is that what controls it?
yeah, so if you have lots of testosterone, what is testosterone telling the pituitary to do? Make more LH or less?
More.
Less.
Less. Oh,
What about GnRH?
make less too.
Right? Yeah,
Because they're together.
yeah, makes sense.
So the testosterone just tells the to not make less of them?
It tells the hypothalamus
And the pituitary.
and the
Because that way, if you have less LH, then you have less testosterone being made, right? Because you've made enough. And it's testosterone's binding to those areas and telling them that. What'd you get for 2 over here? Yep, that's it. That's the idea. What'd y'all say for 2?
We said testosterone tells the hypothalamus to stop producing GnRH. The GnRH tells the pituitary to stop producing LH, and the LH stops producing testosterone in the interstitial cells.
Well, if you're not making GnRH, how can it tell the pituitary anything? Do you know what I mean?
It would just cease at the.
And yeah, so it's the first sentence is perfect, right?
so the testosterone tells how to stop secreting genes.
Yeah, and it also tells the pituitary to stop making LH.
Yeah.
Yeah. hmm
And then, which
But I guess the way
stimulation
that's written, I don't think that's what you mean. But you said, you know, GnRH tells the pituitary to stop producing LH.
I just gotta do that. And then the
Just take that part
pituitary-
off. You're right, the pituitary would stop.
So the pituitary
Stops producing. There you go.
LH.
Yeah.
That sounds good.
Like, testosterone tells hypothalamus to stop secreting GnRH, which then tells the pituitary to stop.
hmm
I just got a word in there.
Yeah. But I know what you meant.
Do you have a question for C on 3?
Oh, what'd you say for 2 first? Let me make sure that one's right.
You came and told us testosterone stops LH.
Oh, right, I told you that. All right, so 3.
We just
In-
said C.
Okay,
Because I don't think it would change the testosterone.
you're right.
Because you have to have testosterone already for the FSH. So would we just put no change?
Well, what does FSH do?
It stimulates the spermatogenesis.
So what would happen to that person?
They wouldn't
Word looking sperm.
produce
Uh,
more.
No, they'd make more of them, right?
Yeah. So it'd be no change
Oh,
to
yeah.
testosterone. But
You're right. hmm Wait, that was C we were talking
Yeah,
about.
I would just
Okay.
forgot to write this one.
All
Thank
right.
you, though.
Sweet. 2, 3.
I love 2 and 3. 1, 2, and 3.
So for C, you guys wrote
It was just getting reproduced all
Which is in turn, you know, reimburse them.
I took that off.
Just right for that third one because it'd be excessive sperm.
Exactly. Mhm.
Yeah.
Oh, so then C would decrease LH for making
less.
yeah.
I think so.
Yeah.
I don't even.
It's hard to get my head right. You narrow it down. Make too much LH. Make too much FSH.
Oh, we did need to do 4. Good job.
I thought it said 2.
Yeah, 2 or 4.
Yeah. So go down.
Yes.
So here, are you wanting to know, like, why there's more? Because, like, something with this isn't working? Or what's going to happen to the person itself if they're making
No, I was just looking for what happens to LH and FSH levels.
So then these would be, like, really high, right? It's like,
Yes.
just like that?
Yeah.
Okay.
Yeah.
Let me hop on this one.
What'd you say for
We're confused.
excessive testosterone? Oh, I wanted to know what happened to LH and
And then
FSH.
on C, you increase it because then your LH is trying to.
For 4, all of them is what happens to LH and FSH levels.
On A, we put it the excess testosterone, and then for FSH. Yeah, but okay, so say for some reason you have an.
So you're saying you're going to have high LH and high FSH? You should write that somewhere. So that's what the question said. You're right about what would happen to the person.
So we just have to say, like, higher or low levels of this.
Yeah.
So then if you have two.
Although it's not a bad idea to write the other stuff maybe, but. So then for B,
So we're confused because it's asking about this and what would happen to this. Exactly.
yeah. So if you make a whole bunch of testosterone,
It would make like a lot of FSH?
LH.
More or less.
More. No?
Less?
Less?
So just on number 2, you told me that testosterone tells these 2 places to stop making those hormones, right?
So if there's more testosterone, there's less hormone.
Right? That's how negative feedback works.
Okay. So there'd be less LH.
No. Yeah?
And then same thing for FSH. There'd be less sperm.
Less FSH.
So less LH and FSH?
So then for C it'd be more, right?
Right. Y'all all right? Wait.
Wait, so
Increase.
Well, would B be decreased because
Yes.
for just some weird reason you have more testosterone?
Yeah, because on number 2, you told me that testosterone goes up here and tells hypothalamus to stop making that,
Okay.
right?
Okay.
And then C
Would be increased.
would be increase.
Okay, so we had a roll.
And I know what you're thinking. You're thinking, what caused that problem?
Yeah.
But I'm asking, like, what if the testes are just doing it?
Yeah.
How would it change the, right?
Okay.
All right, did y'all get those, you think? Increase.
The LH and the FSH would increase. We said LH would be higher, the increase in the LH would increase as well.
So for B, I would say that's not quite right. So what happens if you have lots of testosterone? What did you tell me on number 2? It's going to be decrease of both of them because testosterone tells these 2 places to stop making those hormones, right?
You're on the spot.
So what about 3? If you have low testosterone.
LH would increase.
What about FSH? Except if you have low testosterone, you make more of this.
So then it stimulates it either way.
It stimulates both of them. All right. Stop. Decrease. Yeah, so y'all got those. As long as you got the same thing. All right. All right.
Okay.
I have a couple movies to show you. Y'all signed that waiver, right?
Yeah, right.
So I could put a penis up there.
Everyone over the age of 18 in here.
Yeah. All right. So this is going to show you the pathway that the sperm take from the very beginning. All right. All right.
The testes, seminiferous tubule, epididymis, ducts, urethra, and penis. The seminal vesicle and prostate and mobile urethral glands produce nourishing
full
fluids
screen.
to the sperm. The testes subdivide into lobules that contain seminiferous tubules
There it goes.
that produce sperm. Sperm moves from the seminiferous tubules to the embryo tubules to the epididymis where they mature. The end of the epididymis forms the ductus deferens or vas deferens. This structure ascends the posterior border of the testes, penetrates the inguinal canal, enters the pelvic cavity, and moves over and around the urinary bladder. The seminal vesicles are glands at the base of the bladder that produce seminal fluid. Together with the ductus deferens, they form the ejaculatory ducts. During ejaculation, these ducts eject sperm into the male urethra, common passageway for urine and sperm. The prostate gland surrounds the prostatic urethra just below the bladder. Fluid it secretes goes through small ducts into the prostatic urethra. The bulbal urethral glands produce alkaline mucus secretions that empty into the urethra. The urethra passes through the penis carrying semen, a mixture of sperm and secretions of the glands. During ejaculation, the smooth muscle sphincter at the base of the bladder closes off to ensure that no urine is expelled and that semen does not enter the urinary bladder. Sperm moves from the seminiferous tubule.
So you can see their whole pathway.
The ductus deferens to the ejaculatory duct, the outside of the body by the urethra.
All right. So based on all that, where's this picture? How do you think vasectomies work? Maybe you know already. So down here, so down here, just cut it, tie it off. One crazy story I heard about that at a friend of a friend. This is true. He had vasectomy. He had like a bike accident. Like he fell off and hit like the bar on the bike really bad. And then his wife got pregnant, and he was going to divorce her because he thought she was cheating on him.
I have an army friend who went
Yeah.
to Germany, and after 8 years, it came untied by himself.
It came untied?
Ah, she's pregnant, yeah. The poor guy has like a 27-year-old.
Well, you can impregnate someone up to like, isn't it like months after it's done still?
Really?
Yeah, you have to
Oh, I didn't know that.
Tested. Yeah, you
Huh.
have to go get it tested, make sure that. And then
I wonder
you
why
get
that
tested
is.
After 8
It's
years.
hanging out in there, I guess.
I guess it's where we're hanging out, or maybe it's not completely.
The ones that are left.
Yeah. And so that's why you can get it reversed, right? They just kind of reattach it. Kind of crazy. What do you think happens to what happens to these sperm down here if you cut that off?
They just die off.
Yeah, they're just going to get reabsorbed, get remade. That's what you're saying, like the 2-month thing. You still have some sperm kind of in there and there. Yeah.
So then he got remarried and wants kids, and they said instead of getting like a vascular vasectomy,
Yeah.
he's gonna like go in and get sperm.
Right.
It's like still in there, but it's just not.
Yeah, so you still make new sperm constantly. They just can't get out, so they probably just go in there and take some out of the epididymis and just do IVF, I guess.
That's ridiculously expensive. I'd rather do the reversal.
Because then he'd have to get it.
Oh, right.
So they want to pay like 20, it's not 12,000 for IVF.
Maybe it's not IVF. Maybe there's something in between they could do. Is it? Okay.
They do IUI, which was they take a tube and then put it in the urethra and do a cervix, or not cervix, but into a cervix.
Whoops.
Yeah, right, I was thinking they were going to take a cervix. Yeah, it's called IUI. And
Could you imagine trying not to do it and then be like, okay,
All right. So we're actually going to look at. I had to order new penis slides.
Oh, I remember you said you were still.
Yeah. Well, I had one and disappeared. So we get to look at a penis slide in lab next week. And if you look at super zoomed out, it looks very hollow, right? It's kind of the idea. And so you've got, arteries going in there, and then what's around it is just called, what do they call it? The spongiosa. I can't remember. It's a bunch of hollow areas, basically. So what happens during an erection? It's the parasympathetic nervous system. You remember learning about that one? And it could be brought on physical, mental, or just from high blood pressure. Could even cause it. And what happens is you get a bunch of vasodilation of the arteries, fills up with blood. You know the rest, I hope. I have a 3D animation even.
Male erection begins
Okay.
with stimulation, visual, psychological, or physical. When the brain perceives stimulation and excitement, it sends signals down the spinal cord. The
this
signals
working?
travel to nerve endings in two spongy tubes in the penis called the corpora cavernosa. The nerve endings release the chemical compound nitric oxide into the blood vessels of the corpora cavernosa and surrounding tissues. The nitric oxide stimulates production of cyclic guanosine monosulfate, or CGMP. CGMP causes smooth muscles in the walls of the arteries, bringing blood into the penis to relax. When the walls of the arteries relax, blood flow into the corpora cavernosa increases. At the same time, the walls of the veins carrying blood out of the penis contract, so blood cannot flow out. As the arteries become full of blood, the penis becomes longer and harder, producing an erection. The erection is maintained as long as the nerve endings in the corpora cavernosa receive signals from the brain. When the brain is no longer stimulated, an enzyme called phosphodiesterase, or PDE5, is released. PDE5 causes the breakdown of CGMP. The smooth muscles in the artery walls contract, stopping the flow of blood into the penis. And the walls of the veins relax so blood can flow out.
All right, that was a very mild animation.
You did not at all sound very excited to be saying all of that.
Wow. It's always funny, like in my office, erection animation. They're like, related videos you might like. I'm like, no. Let's no, thank you, YouTube. Thank you. It's terrible. So while we're on there, we may as well talk about Viagra. It's kind of fun. So if you're having, issues with that, Viagra blocks that enzyme PDE5, so you maintain CGMP for a lot longer. And you remember that was the signal from nitric oxide that caused the vasodilation of the arteries, constricted the veins, so it makes that signal last longer.
So you call your doctor after 4 hours.
So that's actually the idea. So, if you do have that problem, then just slowing it down a little bit will make things normal. But, could it be too much? Yeah, that's why they have to say that in the commercials, right? So especially if like a health person who doesn't have that problem, they have normal amounts of all this stuff, that's probably going to have that priapism thing we talked about, where it doesn't go away. Because, you're not getting rid of the signal. All right. And this is one of the only cases where you get sympathetic nervous system and parasympathetic sort of at the same time. And it's sympathetic that actually causes the ejaculation process. And it's smooth muscles that are just pushing everything out. What was I talking about? I think we did all that. We did vasectomies. Did you do the path of sperm when we watched the video?
Yeah. It was hard, and I only did like abbreviation.
I don't remember watching it. I didn't get, it's kind of lost.
We can go back to the diagram real quick. Oops. Too far. All right, so zoom in a little bit. Where's that one? So where did it say to start? Testes, yeah. So they're made in the seminiferous tubule. They go through the right testes to the epididymis. Do you have the first couple steps? So seminiferous tubule, right testes, epididymis. And then after they go there, Then they go through the vas deferens, and one on each side, obviously. So vas deferens, and then they get to the ejaculatory duct, and then the urethra. You don't need to worry about the gland part, because they don't go through the glands, right? They're in those tubules, and the glands are kind of next to it. Right. Have you heard of those special bike seats? Have you seen them? Like they tell men if they bike too much, they can get sterile.
With the gap in
Right? Circulation, and also like that you're sitting on a bike seat, you're sitting, like all that pressure's right there.
You know what's worse than
Or here.
bicycle
What?
is unicycling. You don't even have your arms, you're just crushing those bad boys.
Well, Ross will never have kids.
That's too bad, because unicycles attract women like so much. It's terrible. All right, I guess I'm done with the male stuff. Got any questions? Do I? Oh, they cut the vas deferens before it leaves, like in the testes, basically. So like right around there. So then the sperm can't get out of the testes, really. They just get stuck there. Yeah, next time we'll talk about the birth control methods and the table.